This ship does not launch. There is no countdown, no fire, no moment where everything begins. It is not built on Earth because it is too large, too complex, and too permanent. Instead, it is assembled slowly, piece by piece, in orbit. Sections arrive months apart. Some are never meant to return. When it is finally complete, nothing happens. The ship does not leave. It simply starts accelerating, quietly, continuously. And from that moment on, it will never stop moving. Everything we have built so far is designed to come back. Rockets burn hard for a few minutes, then coast. Missions are planned in months, sometimes years. Interstellar travel works on a different scale. The distances are not just larger, they are absolute. Light itself takes years to cross them. At those distances, speed matters more than thrust. A powerful engine is useless if it can only burn for a short time. What matters is sustained acceleration, small, constant, applied over decades. This changes everything. The ship is no longer a vehicle. It becomes a momentum machine, designed to trade time for velocity. And once it reaches cruising speed, turning back is no longer an option. Interstellar travel is not a mission. It is a commitment. A ship like this cannot be launched. There is no rocket powerful enough. Its mass is measured in thousands of tons, spread across kilometers of structure. So construction happens in space, above the atmosphere, beyond gravity, where size no longer works against you. The ship is built the way cities once were, slowly, modularly. Different sections are assembled in parallel: living rings, power structures, engine components. Robotic systems handle most of the work. Welding, aligning, connecting systems with millimeter precision. Humans supervise from a distance, stepping in only when something goes wrong. Some modules are tested for years before they are ever attached. Others are replaced before the ship is even finished. By the time construction ends, no one remembers a moment when the ship became whole. It was never complete on Earth, and it never needed to be. From a distance, the ship looks unbalanced, long, segmented, unfamiliar. There is no single body, because every section serves a different purpose. At the front, rotating structures create gravity through motion, not for comfort, but for long-term stability. Further back, the ship stretches outward, placing distance between its most fragile systems and its most dangerous ones. Radiation, heat, and propulsion are kept as far away as possible. Every meter matters. The ship is not compact because compact designs fail over time. Instead, it is spread out, deliberately, like an organism that evolved for survival rather than speed. This is not architecture meant to impress. It is architecture meant to endure. At the center of the ship, but never close to its people, is the engine. Not a rocket in the traditional sense, but a system designed to run for years at a time. There is no violent launch, no sudden burst of speed. Acceleration begins slowly, almost imperceptibly. A fraction of Earth's gravity applied continuously, day after day, year after year. The engine does not push the ship forward. It changes what the ship is made of, converting mass into energy and energy into momentum. Several designs are possible: nuclear pulse systems, fusion drives, concepts that exist only on paper for now. What they all share is patience. Given enough time, even the smallest force becomes unstoppable. By the time the engine finally shuts down, the ship will be moving faster than anything humans have ever built, and it will continue on its path, powered by momentum alone. The engine is only one part of the system. To sustain acceleration for years, the ship must generate and control enormous amounts of energy. Reactors run continuously, not to provide comfort, but to keep the ship in motion. Power flows through the structure, along reinforced spines, and layered conduits. But energy creates heat. And in space, heat has nowhere to go. So the ship grows outward again. Vast radiator arrays unfold, thin, delicate, and essential. They glow faintly, shedding excess energy into the dark. Without them, the most advanced engine would destroy the ship that carries it. Every system is balanced, not for peak performance, but for stability over decades. Because in interstellar space, failure does not arrive suddenly. It accumulates silently over time. At interstellar distances, navigation stops being interactive. There is no joystick, no real-time correction. Signals take years to arrive and years to return. By the time a command reaches the ship, the moment it was meant for has already passed. So the ship navigates itself. Its course is calculated decades in advance, based on probability, not certainty. Sensors scan ahead, not for obstacles, but for deviations, measured in fractions of a degree. Corrections are subtle, rare, pre-planned. Most of the time, the ship does nothing at all. It simply continues on a trajectory chosen long ago. Human oversight still exists, but it is secondary. At this scale, machines react faster and remember longer than any crew ever could. The ship does not wait for permission. It makes decisions and lives with them. By the time the ship is underway, most of its decisions are already made. The crew is not there to fly the ship. There is nothing to steer and nowhere to turn. Instead, humans exist as part of the system. They monitor, they verify, they intervene only when automation fails. Their presence is redundancy, biological, slow, but adaptable. The crew is small by design. Every additional person adds mass, energy demand, and long-term risk. So roles are compressed, skills overlap. No one is a specialist in only one thing. They are not explorers in the traditional sense. They are caretakers of a machine that cannot afford to stop. After years of acceleration, the engine powers down, not because the journey is complete, but because it no longer needs to run. The ship has reached its cruising velocity, a speed built slowly, patiently. Now, there is nothing to do but drift. No thrust, no vibration, only motion. Stars no longer hold their familiar positions. They shift, almost imperceptibly. Time stretches. Inside the ship, systems continue their routines, unchanged by the silence outside. The journey is no longer active. It is irreversible. From this point forward, the ship belongs to interstellar space. At this point, the ship no longer needs pilots, or commands, or real-time decisions. Every critical system is automated. Every correction is calculated decades in advance. Every decision can be made faster, without human input. So the question is no longer how we build an interstellar ship, but who it is actually built for. Will it carry us, fragile, biological, limited by time? Or will it carry our combined intelligence, the sum of everything we know, compressed into systems that do not age, do not sleep, and do not forget, able to travel where we cannot? The first interstellar journey might not be humanity's next step. It might be our handoff to something that can finish the journey long after we are gone.